In this video, I want to do a quick review of the kinds of factoring we've talked about so far, factoring trinomials and factoring binomials. If you need a more in-depth look at how to do these, go ahead and watch one of my other videos. Otherwise, here's going to just be, like I said, a quick review. So I'm factoring trinomials in this first part, and notice my a value, my coefficient of x squared, is just a 1. As long as that's the case, what I'm going to look for to factor are two numbers that multiply to my last term and add up to the middle term. If you're good with factors, you can probably do this pretty easily in your head. Otherwise, my advice would be to make a list of your factors of the last term. So for example, factors of 20 could be 1 times 20. We could have 2 times 10. We could have 4 times 5. And those are our only factors of 20. Now, noticing my signs, noticing that I have to multiply to something positive but add up to something negative, that tells me my signs must both be negative. So kind of go through your list of factors knowing that both signs must be negative and find the one combination that's going to work to add up to -9. That's -4, -5. So the way this factored was then x minus 4 and x minus 5. And an easy way to check that would be either to remultiply your answer or graph both your answer and the original expression, and see if they make the same parabola. Okay, so that's how we factored when a was 1. If you want to pause the video and try these next few, go ahead and do that. Otherwise, I will quickly run through these other trinomial ones. Factors of 12 that add up to 3. So let's see, factors of 12 could be 1 and 12, could be 2 and 6, could be 3 and 4. Since I multiply to something negative, I know I must have opposite signs. So I need, like, for example, -12 and +1. Going through my list and trying all those combinations, though, I can see that in this case, none of them add up to +3. It's possible that things won't factor, and this is one example where we can't factor this. There's no combination that works to add up to a +3. This problem would not factor. Next up, multiples of 100, that would add up to 20, -20. So again, I'll make my list, although hopefully you're at the point you can do this in your head. 1 and 100, 2 and 50, I could do 4 and 25, I could do 5 and 20. Again, I need two negative numbers since I want to multiply to something positive but add up to something negative. I need double negatives. Oops, I forgot one set of factors, the one that I would need, and that's 10 and 10. If I make both of those terms negative, -10 times -10 is +100. They also add up to -20. So I would factor that as x minus 10 times x minus 10. Or if you prefer, since it's something times itself, just x minus 10 squared. Okay, and then last up for a quick trinomial review, I need two numbers that multiply to -18 and add up to -3. So again, make your list of factors or run through them in your head. Sometimes as the numbers get bigger, it's helpful to make your list just so you know you haven't missed anything. I need to multiply to something negative, which means I need two different signs, a positive sign and a negative sign. So go through and kind of, in your head, kind of put one sign positive, one sign negative in that list of factors. And you'll eventually see that -6 and +3 are going to be the two that add up to -3. So we'd factor this as x plus 3 and x minus 6. We can factor binomials using something called the difference of two squares method. This method works, meaning we want to make sure that we have a difference. We want to make sure we have a subtraction problem. The 2 refers to the fact that we have two terms, so we're dealing with binomials, and then squares is going to mean we have perfect squares, so numbers we can take the square of and get an integer. So as long as those things are true, we can go ahead and factor with this method. So these problems all kind of fit that. They're difference problems, there's two terms, they're perfect squares, and it comes down to taking square roots. I'm going to take the square root of both terms. The square root of 9x squared is just 3x, so put that in the first spot in both your parentheses. And the square root of 49 is 7, so put that in the back. The only difference in your parentheses is one is plus and one is minus, and that's how the pattern works for difference of two squares. So again, just a quick overview. If you want the full video, go back and find that one. Pause it if you want to try these next two on your own. Otherwise, let it play through, and I'll show you what I did for these. I've got another difference of two squares. It's subtraction. They're both perfect squares. This time the variable's in the back, and sometimes that weirds people out, but it's just the way it is. So just keep the variable in the back. Square root of 121 is 11, so that goes in the front. And square root of m squared is just m. And again, all that's different is you have one positive sign, one negative sign. So m plus 11 and minus 11. And finally, this last one, at first glance, it appears we can't do it. It's not a difference problem, but watch what I'm going to do. I'm going to switch the order around and say p squared minus 100. I haven't changed anything. I've just changed the order of my terms. The 4 is still positive, the 100 is still negative, but now it is the difference of two squares. One other thing to look for before you do difference of two squares, though, always look for a greatest common factor. And in this case, even though 4 and 100 are both perfect squares, there is also a greatest common factor of 4. So pull that 4 out first. Always look for a greatest common factor before you do any kind of factoring. And now what's left over is still difference of two squares. So I can factor that again as, p plus 5 and p minus 5.